And here we go with lesson 3 of the Year 10 Triple Science topic, Structure and Bonding 2. We study the structure of atoms and bonds so we can improve the properties of materials and chemicals. Now, last time that was about transition metals. So here's a quick quiz to test your memory of last lesson. Pause the video. You don't need to write it down. Just think to yourself, true or false. Pause it now. Okay, let's go through the answers. Number 1, true. They are found in the central block of the periodic table. Number 2 is false. That central block is actually between groups 2 and 3. Transition metals have high density and high conductivity. True. They have high melting points. Number 4 was false. They make good catalysts. True. They have a variety of charges on their ions. So that one was false. Copper can be 1 plus or 2 plus. Iron can be 2 plus or 3 plus. Roman numerals are used to denote the positive charge. True. For example, iron III, that means 3, so 3 plus, yes, true. Copper 2 plus is formed when copper atoms lose 2 electrons. That one was false. And Cu2O contains 2 lots of copper 1 plus. So that was false. Now, we are going to look again at the transition metals, this time their physical and chemical properties. Okay, now here we go with the first chemical property. They can react with oxygen. Okay, you'll will have done at some point magnesium burning in oxygen. You might have burnt iron wall in oxygen, or seen your teacher do that. Well, iron is a transition metal, so it can react with oxygen. And like any metal, when it reacts, it forms an oxide. So here we have pure oxygen in this glass. So they're using a Bunsen burner to get it started. And then it's going into a flask of pure oxygen. And that will make it burn more brightly than in air. But what will also happen is that the iron will change into a new product, iron oxide. Just like when magnesium burns to form magnesium oxide, iron burns to form iron oxide, copper will form copper oxide. Apologies for that. And there we can see the copper oxide, black substance on the transition metal. All right, let's keep going. Well, yes, that black substance is copper 2 oxide. Okay, so we learned last lesson that means a 2 plus ion. And all transition metals can react with oxygen to form oxides as long as they are not totally unreactive. Like gold and silver are transition metals, but they're right at the bottom of the reactivity series, so they don't react with oxygen. But anything that is reactive will react with oxygen to form an oxide. Okay, pause the video and just check, what do these Roman numerals mean? Here we go with the answer, hopefully straightforward. Copper 2 plus ions in this oxide, iron 3 plus ions, and then titanium 4 plus ions in these oxides. 4 plus ions are pretty difficult to form. It's difficult for an atom to lose 4 electrons, so it doesn't necessarily form that ion exactly, but we've referred to this as its oxidation state. It is in the oxidation state of plus 4. Okay, very briefly, put it into a sentence. This is practice for when the writing task is coming up later, so you don't need to write it down now. Just think, what would your sentence be? Describe the reaction of transition metals with oxygen. Think of a sentence now, please. Pause the video. Right, let's see, what did I put for my sentence? When metal reacts with oxygen, they form oxides. For example, copper plus oxygen makes copper oxide. Nice and easy, nice and straightforward. Now, because they form a range of ions, their oxides can have a range of chemical formula. Oxide is always O2 minus. Right, so we looked at this a bit last lesson. Right, so just to go through it again, a 2 minus ion can attract 1 lot of a 2 plus ion. So copper 2 oxide, the ions bond in a 1-to-1 ratio, and we get copper oxide, CuO. However, with titanium, if that is in oxidation state plus 4, it will be able to attract 2 lots of a 2 minus ion. Okay, therefore, 2 oxides will attract to each titanium, and the chemical formula will then be TiO2, because every titanium attracts 2 lots of oxide. Okay, now this one, iron. If iron is in its 3 plus state, a little bit more complicated, right? In order to balance the charges, we would see that 2 3 plus ions would attract and bond with 3 lots of 2 minus ions. Then we have 6 pluses attracting 6 minuses. Now to write that as a chemical formula, 2 lots of Fe bond with 3 lots of O. So we get the formula Fe2O3. Now, if you see this formula and you need to check, is it iron 2, is it iron 3? 3 lots of oxide makes 6 minus. Therefore, iron altogether must be 6 plus. If there's 2 of them, there must be 3 plus each. That's the formula of iron 3 oxide. Okay, so iron 3 oxide is Fe2O3. Now, transition metals can also react with halogens from group 7, chlorine, bromine, iodine. So there's group 7 there from the periodic table. And when they do so, they form well, in this case, iodine is reacting with iron. So that will react to form iron iodide. If it's bromine reacting, it will react to form iron bromide. If it's chlorine reacting, it will react to form iron chloride. Okay, so there's iron chloride forming in that tube there from the reaction of iron and chlorine. Okay, so when transition metals react with group 7 elements, which are sometimes called halogens, they form salts: chloride, bromide, iodide. Now, the general name for bromide, chloride, and iodide is halides. Halogen elements, when they go in a compound, are called halides. So here we have silver bromide, iron chloride, and titanium chloride as 3 examples of transition metal halide salts. So transition metals react with halogens from group 7 to form salts, right? And the second part of the salt name will always be bromide, chloride, or iodide. Right, now let's have a look at the equations. Copper 2 chloride. In fact, yeah, okay, let's just pause for a moment. As an element, chlorine is Cl2. And because it's making copper 2 chloride, the formula for that is CuCl2. So here we have a balanced equation for copper reacting with chlorine gas, Cl2, to make copper chloride. Right, now I can tell it's copper 2 chloride because chloride will be a 1 minus ion. 2 1 minus ions will attract with a 2 plus ion. So that must be copper 2 because it is attracting 2 lots of chlorine 1 minus. Let's have a look at iron. Now in this particular chloride, we've got Fe plus Cl2, that's the formula of chlorine gas, reacting to form iron chloride. But because it is iron 3 chloride, iron is 3 plus, therefore it attracts 3 lots of chlorine minus. Now that's an unbalanced equation, so that's going to need balancing. So, are we going to balance it now? Let me just skip ahead. I'm not quite sure what I've done with that. Right, let's just balance it now. This would need, to balance the number of chlorines, you would need 6 on both sides. So 2 lots of FeCl2. In fact, let me get the pen up. Forgot I could do that. Right, let's just write this out. Fe and then Cl. Excuse my terrible writing. Cl, Cl. On this side, Cl, Cl, and then Fe. Right, now then, I don't have enough chlorines on this side, so let's put a 2 in front of that. Well, if I put a 2 in front of that, I would get another 2 chlorine atoms. Then I would need more on this side. So I need 2 lots of FeCl3. So let's stick that in here. FeCl, Cl, Cl. So I've got 1, 2, 3, 4, 5, 6. I need another 2 Cls over here. So that's a third lot of Cl2. Right? So it takes 3 lots of chlorine to balance 2 lots of FeCl3. But I've got 2 Fe's on this side, so therefore I need 2 in front of that. So that is now the balanced equation. 2 lots of iron react with 3 lots of chlorine to make 2 lots of FeCl3. So a quick bit of revision of balancing equations for you there. Okay, right. Let's keep moving. Okay, so what is a halide? It is the -1 ions of group 7. Fluoride, chloride, bromide, iodide. They always form -1 ions, and they're called the halides. Right, can you put this in a sentence? Without balanced equations, without formula, just a short sentence describing, well, it says explain here, explain what happens when a transition metal reacts with a halogen from group 7. So don't include any equations or formula, just think to yourself, a general sentence, what generally happens when transition metals react with halogens. Pause it now. Here we go with my answer. I said the metal reacts with the halogen to form a salt. The salt is called a halide. It contains the 1 ion of group 7 like chloride, bromide and iodide. I've put an example here. Iron plus chlorine makes iron chloride. So aside from all of the formula and equations, the general idea is metal reacts with group 7 to form salt. And salts always contain chloride, bromide or iodide, and they are the 1 ions of group 7 called the halides. Right, okay, here we go. Can you work out the formula of these transition metal halides? Remember that the halides are always 1 So can you work out what the formula would be if they went with silver 1 copper 2 iron 3 or titanium 4 Pause the video, see if you can think in your mind, what would the formula of these salts be? Okay, let's look through the answers. Right, if iodide is 1 then silver 1 will attract one lot of that, it will be AgI. Copper is 2 it will attract 2 lots of chloride, CuCl2. Iron is 3 it will attract 3 lots of bromide, iron Br3. If titanium is in oxidation state +4, it can attract 4 lots of fluoride, TiF4. It always gets more difficult when we start including formulas and equations. Right, now think about this. Which of these are chemical or physical? If it's reacting with oxygen to form oxides, that is a chemical property because it involves a chemical reaction. If it reacts with halogens to form halides, that is a chemical property because it's talking about a reaction. So both of these are chemical properties of transition metals. They react with oxygen to form oxides and they react with halogens to form halides. Chemical properties. Now, think back to last lesson. What were the physical properties of transition metals? It was also, some of them were in the starter quiz at the beginning of the lesson. So pause the video and how many physical properties of transition metals can you list from last lesson? Pause it now. Okay, here come the answers. High melting points, good conductor of electricity and heat, malleable, ductile, strong, shiny. Okay. What about catalysts? That's more of a chemical property because catalyst is speeding up reactions. Okay, right, hinge question time. We are nearly ready to start doing the writing task. So pause the video. Is the correct answer A, B, C, or D? Let's have a look at the answer. The correct answer was B. They react with oxygen to form oxides, and they react with halogens from group 7 to form bromides, chlorides, or iodides. Okay, those are the chemical reactions and the chemical properties of transition metals. Right, there's one correct answer on the screen. Pause it and work out if it's A, B, C, or D. Here we go. Correct answer was C. The chemical properties include reactions with oxygen, halogens, water or other reactants. We haven't really talked about water at this stage. The reason for putting water in there is because next lesson we're going to compare the transition metals to the alkali metals. The alkali metals react vigorously with water. If you think about something like iron, water and air can help it to rust slowly. So transition metals don't react a lot with water, but it is possible for water to help them corrode. Right, but in general, chemical properties might include reaction with water. For example, we'll see that with the alkali metals. Next lesson. Right, here we go. Driving question. What are the physical and chemical properties of transition metals? Right, I've got some sentence starters here. When metal reacts with oxygen, what happens is, and you can read through that, pause the video for as long as you need, listing the physical properties, that comes from last lesson. The chemical properties are what we've looked at today, but then here it starts to get harder with chemical reactions, trying to work out, trying to balance equations basically, and then naming the products. So look at the product and decide whether you think that is copper 2 oxide or copper 1 oxide, and work out the Roman numerals for each name of the product. With blue, you need to look at the next slide for that. So do orange, green, and yellow from this slide, then you can have a look at the next slide for the extension. So pause the video for as long as you need. It gets really difficult with these balanced equations and naming the products, but have a really good go, okay? See if you can figure it out. Pause the video now. Right, moving this on to the extension slide. There are some descriptions here. You might want to refer to a periodic table. You can always Google the periodic table if you want to have a quick look. What do you think these elements might be. Where might they be on the periodic table? Are they transition metals? Are they in group 1? Are they in group 7? Are they noble gases? Is it a metal? Is it a non-metal? Try and look at the properties and decide as much as you can, what do you think that element is? It's a prediction, so you might be not completely right or partly right. Just see if you can figure it out. Okay, going to move this on to the answer slide now. Okay, so remember that you are allowed to write more in. If you didn't get something, you're allowed to write it in now. Starting with the easy bits. Transition metals react with oxygen to form metal oxides, right? And then they also, transition metals react with halogens to form salts called halides. The halides, that refers to the 1- ions of group 7, for example, fluoride, chloride, bromide, and iodide. So transition metals, their chemical properties are they react with oxygen to form oxides, and they react with halogens to form halides. Summarizing the properties, physical properties from last lesson: high melting points, good conductivity, malleable, ductile, strong, shiny. And chemical properties: react with oxygen to form oxides, react with halogens to form halides like chlorides, bromides, and iodides, and they also make good catalysts. They speed up reactions. Here we go. You can pause the video and you can mark your work, your examples. Just note that I've put the names of the chemicals here as well, with the Roman numerals in. So did you get the balanced equation correct? Did you get the name of the chemical right? Pause the video until you've managed to mark your work. Moving on to the answers to the extension. Right, now extract of potash, highly reactive, reacts immediately with water, purple sparks. It sounds a lot like potassium. Okay, so it's group 1 alkali metal. Wolfram, not its real name, high melting point, conducts electricity, ductile, low reactivity. It sounds like a transition metal. The real answer is tungsten, okay, but it's got the properties of a transition metal. What could this be? Brown red liquid at room temperature, poisonous, similar to chlorine. It's a halogen, and in fact the orange liquid halogen is bromine. This one, lustrous, hard, silver grey, sounds like a metal, forms salts, magnetic, and in fact it turned out to be cobalt. It is a transition metal. There's only 4 magnetic metals, and that is iron, steel, cobalt, nickel. So it has to be one of those 4. And this one's a hard one. It's got an intermediate melting point, so it's not quite like a metal, not quite like a non-metal. It's not very good at conducting electricity, but it can conduct. And this is a bit of a tricky question. It's a semi-metal, right on the border of metals and non-metals. In fact, selenium has these properties. Okay, some challenging work there. What have you managed to achieve today? Were you able to say, today I achieved describe, because I can describe the reaction of metal and oxygen? Is it today I achieved explain, because I can explain the reaction of metal and halogen? Could you summarize the physical and chemical properties of transition metals and start to include some equations and formula? Could you predict the position of elements on the periodic table from their properties? Okay, now next lesson we will be comparing transition metal properties to group 1. In the meantime, don't forget to go back on Show My Homework, click on the Show My Homework entry for this lesson. There is a 10-question quiz to complete as well. And then, next lesson will be about comparing transition metals to the group 1 alkali metals. Well done for your work today. Keep up the effort. Thank you very much.